Section 1.1, simple interest. Okay, our goals are going to try and solve problems that involve simple interest. So here's an example. Sarah is 20 years old and needs money to pay for college. When she was born, her grandparents bought her a $500 Canadian savings bond with a term of 10 years. They chose a CSB, so you're going to see throughout the textbook it'll say CSB, and that's what they mean is Canadian Savings Bond, as an investment because they liked the security of loaning money to the government. So Canadian Savings Bonds is you give your money to the government, and the government says, okay, I'm going to use your money for 10 years. In those 10 years, I'm going to invest in industry. I'm going to invest in roads. I'm going to invest whatever the government invests in. Actually, roads might be provincial, but they're going to invest in that, and because you have lent them their money, they're going to give you money back. Because the idea is Canada's making money on your money. It's been able to start new things, and then it's going to give you some money back. The interest earned was determined using a fixed interest rate of 6% per year on the original investment. Another word for original investment is principal, okay? And it was paid at the end of the year until Sarah's 10th birthday. So the interest is only on that first original amount, only on the $500. Throughout this chapter, there's a lot of vocabulary. So anytime you see a green highlighted word, it's going to be along the side of your textbook and also at the back of your textbook. So the term, we said we had a term of 10 years, that's how long the investment is. The interest is the amount of money that's going to be earned on an investment or paid on a loan. We're talking about investments right now. Fixed interest means that the interest rate is guaranteed not to change. So once you get a little bit older and you have a mortgage, you can have a fixed rate mortgage or a variable rate. And a variable rate depends on the economy. So it could go up or it could go down. So it's a little more risky, but could end up being less money than a fixed rate. If you got a fixed rate of 9% and then the economy is really good and the interest rate went down to 4%, then you're paying 9% instead of 4%. And principal is the original amount. So simple interest, we're looking at the principal. We're only getting interest on our principal, not on our interest. We're not getting interest on interest. That's called compound. Okay, question number 1. How much interest was paid on the principal at the end of the first year? So grandparents put $500 in. They were guaranteed 6% interest. They made $30. Okay, so that's just some simple math there. At the end of the first year, they made $30. Determine the simple interest earned each year, the accumulated interest, and the value of the investment for the first 4 years, and we're going to organize it in the table. So year 0, they put $500 in. We already did this first one. So at $500, they earned $30 interest. So far, all the interest they have is $30. And at the end of the year, they really have $530. Okay? Year 2, their investment is worth $530, so we've carried that over. The interest they make is still only on that $500. They only make $30. So in total, they've made $60, and their total of their investment is $530 or $560. Okay, continuing on, $560. We add another $30 onto that. We get $90 total, $590, and we'll continue in year 4. Okay. So question C, is simple interest earned each year a constant or is it a variable? So what they're basically asking in this column, is it the same number or does it change? It's obvious that that is constant. It never changes. It's always the same percent of the same principal. It's always 6% of $500 or $30. Describe the relationship between the number of years, the interest earned each year, and the accumulated interest. Okay? This is question D. So we're looking at compare year, interest earned, accumulated interest. So as the years get higher, simple interest stays the same, but accumulated interest increases. And this relationship could be looked at as I, interest, is equal to the principal times the rate times the time for simple interest. Okay, so let's look at year 4. So the interest earned in year 4 is your principal, $500, times your rate, times time in year. So it was 4 years. We said that 500 times 0.6 is 30. So we have 30 times 4, and that is equal to 120. Wow. Here we go. So as the time increases, your accumulated interest goes up. Your interest earned each year stays the same. Okay? Use the relationship from part D to predict the value of the investment after 10 years. So now what we're going to do is we're going to put a 10 there, and that'll tell us how much accumulated interest there is, but then I still have to add my principal on. Okay? So another formula that you're going to see that describes just what I said is A, or your future value, is going to equal your principal, so what you started with, plus all the interest you've earned. Remember, we just said interest is equal to PRT. So we're going to go plus PRT. So your principal plus all your interest. That's all that says. Okay, so we want to know after 10 years. Well, she had her $500 she started with, plus her interest. Well, it's 500 times the rate, 0.06 rather, times the time, 10 years. So we get 500 plus 30 times 10, which is 300. So at the end of 10 years, she has $800 for college. Graph the growth of the investment until its maturity at 10 years, using time as the domain value, and the domain, time is the domain, and value in the investment as the range. So this is your x value, this is your y value. That's what range means. So we're going to have value here, and we're going to have time there, and we're going to plot it. So what that means at time 0, we're going to have a dot at 500. At 4, we're going to have a dot at 620. We're going to have dots all the way along. We're going to graph that. Oops, not yet. And so until its maturity. Our last point is going to be at 10. Okay? So here I've graphed it. I want you to notice a couple good things about this graph. First of all, labeled axes and units. This is in dollars, this is in years. I'm not saying 6 months, I'm not saying 6 seconds. It's very clear. There's a very nice title. You'll notice also that it's discrete, okay? It's not continuous. We don't know the values in between, and actually there are no values in between because you don't get your interest until the end of the year. Halfway through the year, you don't get $15. Okay, it's just at the end of each year. Question D, describe your graph. What does the shape of your graph tell you about the type of growth? Well, this looks like a linear graph. Okay, it's a series of discrete points in a linear increasing pattern. So it shows growth at a constant rate. The discrete points indicate that there is no growth between the points, only from the end of one year to the next. Next question. What does the y-intercept and the slope represent? So here's our y-intercept. Well, that's our principal. That's what we started with. Our initial investment at time 0 was $500. What does the slope tell you? So what does the rise and the run? Rise and the run? Well, it looks like we rise 30 and we run 1 year. What does that tell us? The slope is 6% of the principal. That's how much interest we make each year. Okay. Question I, describe how the value of the investment would change in each situation compared with the original. Explain why. If the principal was $1,000, but the interest rate was still $6,000. Okay, so now instead of starting at 500, we're going to start at 1,000. So now we're going to have the rate is still the same, the 6% is still the same, but we're going to have, it's still a 6% rate, but it's going to be more money that we start with. So the value of the investment would be greater because the interest earned per year would be double. So instead of earning it on 500, it's 1,000, so 6% of 1,000, we get $600 each year. So actually that would be a much higher slope. Okay? B. Principal was 500, but the interest rate was 5%. So we'd still start here, but we'd have less. We'd earn it slower. Okay? The value of the investment would be less because the interest earned per year would decrease. C, Okay, so if the principal was 500 and the interest rate was 6%, but for 2 terms of 10 years. Okay, so now we're just going to extend this graph another 10 years. So we're going to get more money at the end. Okay, a couple of key terms, and this is found in your textbook. Simple interest is determined only on the principal, only on the initial investment. The value of an investment that earns simple interest over time is a linear function. The accumulated simple interest earned over time is also linear. Since the interest is paid at the end of each period, the growth is not continuous, so we only have points. For example, the following graphs show a principal of $300 invested at 5% interest, paid annually over 10 years. So this first graph is the value of the investment, and this is the accumulated interest. Okay. Next slide here talks about using those formulas. I equals PRT, so your interest equals your principal times your rate times your time. And the future value, the amount of an investment, is going to be P plus PRT. So that's important as well. Okay. Unless otherwise stated, interest rate is assumed to be annual or per annum, per year. Interest can be paid out at different intervals, such as annually, semi-annually, monthly, weekly, and daily.